Hello everyone. In this video, I will explain solutions of three problems of projection of point. This is first problem. I have not written complete statement of the problem. Instead of that, I have written the data given in problem in short. The first problem is point A is 30 mm in front of VP and it is 40 mm above HP. Point A is 30 mm in front of VP and 40 mm above HP. This point 30 mm in front of VP and 40 mm above HP. Let me write this. This front distance is 30 mm and this above distance is 40 mm. As the point is above and in front of above HP and in front of VP, that's why it should be in first quadrant. That's why it should be in first quadrant. To get front view of this point, we are supposed to project this point on vertical plane such that we will get its front view as A dash. To get top view of this point, we need to project this point on horizontal plane and the top view is small a. Now after getting projections of this point on VP and HP, we are supposed to rotate this horizontal plane through 90 degree. We are supposed to rotate this horizontal plane through 90 degree. See, this distance is 30, this is also 30. These two distances are same. And as we have rotated through 90 degree, this distance is also 30. Therefore, after rotating this horizontal plane through 90 degree, this top view earlier which was in this horizontal plane, it will lie exactly below this front view. A dash and A will fall on same vertical line. Okay. Therefore, to locate this front view, I need to draw a vertical projector or projection line of what length? 40 mm, and I have to locate this front view A dash at 40 millimeters distance. And to draw top view, I need to draw this projector below XY line of what distance? 30 millimeters. So as to get the top view of this point as A. Top view of this point as A. Simple. The above distance is to be taken above XY and the first front distance is to be taken below XY. As we have rotated this horizontal plane through 90 degree, the horizontal distance, this horizontal distance will become vertical. This horizontal distance will become vertical. That's it. Now we will move to next problem. Now next problem is point A is 30 mm above HP and 40 mm behind VP. 40 mm behind VP. As the point is behind VP and above HP, it should lie in second quadrant. It should lie in second quadrant. To draw projections of this point, that is front view and top view, we need to project this point on vertical plane to get its front view. This will give you front view as A dash, front view as A dash. To get the top view of this point, we need to project this point on horizontal plane, okay, such that it will give us the top view as A, the top view as A. After getting front view and top view, what is the next step? We are supposed to rotate this horizontal plane through 90 degree. This front part of the plane is coming down and this rear part means the back part will go up. This part will go down and this part will go up. Therefore, see, if I complete the what we say, the rectangle or parallelogram, whatever parallelogram. Okay, these two distances are same, and these two distances are same. Okay, now let us try to draw projections of this point for problem number 2. First, draw xy line. Straightway draw this front view. Where it will be? It is 40 mm above xy line. Take 40 mm distance. Draw this front view here as a dash. This distance is 40 mm. And to get the top view, this top view, as we are rotating this plane through 90 degree, this part will go up, and this point, okay, 30 mm will lie on this vertical line after rotation. Earlier this distance was horizontal. It will become vertical after rotation. After rotation, this distance will become vertical, and this top view will come here. Okay, front view and top view will lie on same vertical line, but on the same side of xy line. Therefore, where should be this top view? It will be at 30 mm distance from xy line. 30 mm distance from xy line. This is the solution of this problem. This is the solution of this problem. This is front view, a dash, 40 mm above xy and 30 mm above xy. It will give you the top view. Okay, let us move to third problem. In this problem, it is given that point A is 35 mm below HP and 20 mm behind VP. 20 mm behind VP. As the point is below HP and behind VP, it should be in third quadrant. To get front view of this point, we are supposed to project this point on vertical plane. Okay, this will give you front view, a dash. Now, where we are getting front view? Below xy. When the point was in first quadrant and second quadrant, that time we were getting front view above xy. But when the point is in third quadrant, we are getting its front view below xy. Even if it is in fourth quadrant, then also the front view will be below xy. For first and second quadrant, the front view will be above xy, and for third and fourth quadrant, the front view will be below xy. Now let's talk about top view. To get a top view of this point, I have to project this point on horizontal plane. Okay, this will give me top view. Okay. First of all, let us draw front view, okay, which is very clear from this diagram. To draw the projections of this point, draw xy line, reference line first. This below distance is how much? 35 mm. This distance 35. This is also 35. Okay, and this behind distance is 20 mm. See, this is also 20, opposite sides of parallelogram. These are projectors actually. Okay. Now let us draw this front view first. For that, from XY line, we have to move in the downward direction by what distance? 35 mm. And this will give us the front view. The front view. Give the dimension. I will make separate video on dimensioning techniques. Okay. 35. Now top view is left. We got this top view on horizontal plane, but after getting top view on horizontal plane, the next step is to rotate this plane through 90-degree. Okay, this front part will move down and this rear part will move up. Okay, therefore the point which was earlier here will come above this front view, above this front view. This will be the let me pick up the chalk. This will be the new position of top view. This will be the new position of top view. As we have rotated this through 90-degree, this part will go down and this part will come up, such that A dash and A will lie on same vertical line. Same vertical line. Where we are getting now? See, what is this distance? 20. Because it is 20 mm behind VP. This distance we have to take 20, and this is giving us the top view. Now give the dimension. This behind distance will come here. No, the front view is below XY and top view will be above XY. Very important point. See, blindly we can remember this, okay, without thinking much. Okay, if you remember this thing, you'll not come across any mistake. Okay, you will not commit any mistake. See, when the point is in first quadrant, it is some distance above HP and some distance in front of VP. Okay, therefore we will get front view above XY, A dash, and what about top view? It will be below XY. It is A. Okay. See, the above distance, it should be taken here, and the front distance should be taken here. This is valid for first quadrant. This concept is valid for first quadrant. Now, if the point is in second quadrant, that is, it is some millimeters above HP and some millimeters behind VP. Okay. No doubt we will get front view above XY only. Therefore, first of all, we will draw the front view first, A dash. Of course, this is above distance. And what happens to that behind distance? Behind distance will move up because as the point is in second quadrant, the back portion of that horizontal plane on which the top view is lying, it will go up. Therefore, here we will get front view as well as top view both above XY. See, above and behind, for both these things we have to go up with reference to xy line. What does it mean? When the point is in second quadrant, front view as well as top view will lie on the same side of xy line, and that too above xy, and that too above xy. This is valid for second quadrant. Let us use some different chalk. Okay. Now let's talk about third quadrant. When the point is in third quadrant, it will be some millimeters below HP and few millimeters or some millimeters behind VP. Okay, below HP means we will get its front view on vertical plane, that is below XY. Therefore, it's very easy to draw the front view. Okay, what is that? A dash. Now in this case, as the point is in third quadrant, we are getting front view below XY. In earlier two cases, we were getting front view above XY in both the cases, first and second quadrant. In third quadrant, where we got this front view below XY. And what was the description? The point is below XY. Below. Now it is some millimeters behind VP. Some millimeters behind VP. After drawing its top view and the back side, rear side of that horizontal plane, and after rotating that top view, it will come above XY line. That top view will come above XY line and on the same vertical line through A dash. Okay. Therefore, where should be top view? Okay. As per the distance given, top view will be here. Top view will be here. See, opposite of first quadrant is third quadrant. This is valid for third quadrant. This is valid for third quadrant. Now let's talk about uh, fourth quadrant. When the point is in fourth quadrant, what should be the description of point? It will be some millimeters below HP and some millimeters in front of VP. Below HP, once again we will get front view on vertical plane, that is below XY. As the point is below HP, okay, we'll get front view below XY. Okay, what is that? A dash. What wording should be used? Below. Now the question is, where should draw the front view? Okay, the point is in fourth quadrant below HP and few millimeters away from or in front of VP. That when we draw its top view, for that we need to project that point on horizontal plane to get its top view. We have to go up from that location to get its top view. Once you project that point on horizontal plane, that is frontal part of horizontal plane, and when we rotate that plane through 90 degree, that front part will go down. Therefore, here the front view as well as top view will fall on the same side of XY line. Okay, where we will get the top view on the same vertical line but below XY. And what wording? It is in front of VP. Front. This is front distance. Okay. See, if you observe carefully what is happening in case of second and fourth quadrant. This is the fourth quadrant. In second and fourth quadrant, both the views, front view as well as top view, we are getting on the same side of XY line. In Second quadrant, we have obtained front view and top view above xy line on the same side, and in fourth quadrant we got front view and top view on the same side of xy line and below xy. Okay, this means that when we use the second and fourth quadrant, there may be overlapping of views if both the distances are same, that is behind and above distance, front and below distance are if suppose these two distances are same, then there will be overlapping of views. That's why second and fourth quadrant is not used for the graphics purpose. Okay, when we use either first quadrant or third quadrant, we clearly get two different views on two different sides of xy line. If we use first quadrant, then we get front view above xy and top view below xy. If we use third quadrant, then we get front view below xy and top view above xy. Clearly distinct projections we get on different sides of xy line. That's why always first and third angle method, third quadrants are used. And if we keep point, line, plane or solid in first quadrant, and then if we draw the projections, drawing projections means drawing front view and top view, then such a method of projection is known as first angle method of projection. What is first angle method of projection? When the object is placed in first quadrant and the views are drawn, then it is called first angle method of projection. And what is third angle method of projection? When the object is placed in third quadrant and the views are drawn front view and top view, then such a projection is known as third angle method of projection. To avoid the complications or some complexity, so far we have avoided to draw the side view. Drawing side view is very easy, but purposely I have not mixed the three views. The students, many of the times the students watching these videos are the beginners. Therefore, once we get the command on drawing front view and top view, then easily we can add the that additional part, that is drawing the side view. Okay, that is not a big deal. Okay, simple thing. Above distance is for first quadrant, above distance is taken above xy, front distance is taken below xy. In second quadrant, above and behind distances both we have to take above xy, such that we will get both the views above xy. Third quadrant, below distance it should be taken below, and what is the position of that point with reference to vertical plane in case of third quadrant. When the point is in third quadrant, it will be behind VP. This distance will be behind VP. I forgot to write this, behind. And in fourth quadrant, front and below distances both will come below xy line in fourth quadrant because of the overlapping of planes VP and HP. Okay, the after rotation of horizontal plane, the frontal part of that HP and vertical plane will overlap, and two views gets overlapped. And same thing happens, the rear part and the upper portion of vertical plane will overlap in case of second quadrant, that is second angle method of projection, which is not used. But the present scenario is, nowadays this third angle method of projection has been outdated. Now the whole world is adopting this first angle method of projection. Um, After few videos, we will discuss the symbol used for first angle method of projection and third angle of method of projection, because the person who is watching the drawing sheet, you should understand by which method this drawing has been drawn or made. For that, one symbol for that method of projection is drawn, okay, on that sheet at the end of the sheet. I hope you must have understood this concept. Just think logically. Imagination is very important in graphics. Uh, it it will not take just mugging up the things like other subjects. Okay, if we learn some statements or laws or principles or derivations, we need to memorize those things again and again. Okay, but in graphics, once you learn the concept, once you build the habit of thinking, imagination, then there is no need of uh, taking extra efforts and hard work. Just it needs the imagination and understanding. Once you understand the concept, you can produce the drawing at any time without revision, without studying. Okay, this is one time learning subject. Once you learn the subject, finish. You will not forget up to your death. Trust me. Thank you.